Good evening, everyone. My name is Lucille Gulley, and I'm excited to welcome you to this presentation titled Fate and Transport of PFAs. As you can see on the title slide, PFAs, short for per- and polyfluoroalkyl substances, are front and center. The letters are partially submerged in water and filled with everyday items like fire extinguisher, frying pan, and these visuals represent the many ways PFAs show up in our lives, from consumer products to industrial uses, and hint at the environmental challenges they pose. Today we'll be exploring how these persistent chemicals move through our environment, how they end up in places like our water supply, and why understanding their behavior is critical for public health and environmental safety. So let's take a look at slide 2. What is PFOA and why should you care? On the left side, you'll see the chemical structure of PFOA, which stands for perfluorooctanoic acid. It's a man-made compound with a long chain of carbon atoms, each bonded to fluorine, and it ends in a carboxylic acid group. This structure makes it incredibly stable, so stable in fact that it doesn't break down easily in the environment or our bodies. Now on the right side, we have an infographic showing how PFOA can enter the human body. It highlights 4 main exposure pathways: drinking water, food, soil, and air. All of these connect to a central point labeled PFOA, which then leads directly into the bloodstream. That means once we're exposed, this chemical can circulate throughout our bodies. So why should we care? Because PFOA's persistence and ability to accumulate in our systems raises serious concerns about long-term health effects, and understanding how it gets into our bodies is a first step towards reducing exposure and protecting public health. Now let's move on to the toxicity profile of PFOA. On the left side of the slide, we see how PFOA enters the human body. There are 3 main exposure pathways: ingestion through contaminated food or water, inhalation from dust or fumes, and through less common, absorption through the skin. The illustration shows a person drinking from a glass containing PFOA, emphasizing how easily this chemical can make its way inside us. And on the right side, we get a closer look at what happens once PFOA is in the body. It's absorbed through the gastrointestinal tract and doesn't just pass through, it stays. The diagram highlights several organs that can be affected: the brain, heart, lungs, and the GI tract. These are marked in red to show the potential areas of concern. So the takeaway here is that PFOA isn't just persistent in the environment, it is persistent in us. And once it's in, it can impact vital systems, which is why understanding its toxicity profile is so important. Alright, now let's take a look into how PFOA moves through the environment and why it's such a concern. PFOA is a man-made chemical that is incredibly persistent. It doesn't break down easily in soil, water, or even under sunlight. Once it's released, whether from manufacturing sites or landfill runoff, it could travel through surface water, into groundwater, and eventually end up in our drinking water systems. It also moves through the air, settles into soil, and leaches onto our water sources from there. What's especially troubling is that PFOA bioaccumulates, meaning it builds up in living organisms over time, particularly in top predators, including humans. So even small exposures can add up, leading to long-term health risks. And this slide emphasizes how widespread and resilient this chemical is, and why monitoring it is so important. So PFOA is one of the most notorious PFA chemicals, persistent, toxic, and found in drinking water across the country. So this is why the EPA stepped in. Back in 2016, the EPA issued a health advisory. Fast forward to 2021, they finally got national standards proposed, and by 2024, we're just now expecting enforceable limits to start kicking in. So why PFOA specifically? There are 3 big reasons. One being it sticks around in the environment, like it really sticks. 2, it's been detected in drinking water in multiple states. And 3, it's strongly linked to health risks, especially cancers and liver damage. The bottom line is that the EPA's goal is to reduce exposure and protect vulnerable populations. That means kids, the elderly, and communities with high contamination risk. Here on the right, we have a quick look at the PFAS compounds currently under the EPA's regulatory spotlight. So we got the PFOAs, which is linked to cancer and liver damage, PFOs, known to affect the immune system, and Gen X, which is a newer replacement chemical, but it's still associated with liver and kidney issues. So even though these compounds vary, the health risks are still serious, and this table makes it clear as to why regulation matters, not just for one chemical, but for the whole class of PFAs. While analyzing PFOA levels in public water systems using the EPA's monitoring dashboard, I found that one system in my area, White Lake, Michigan, reported a result exceeding the minimum reporting level, MRL, of 0.003. Although this was a single exceedance, it's still significant, and it indicates detectable levels of PFOA in the local water supply, which could pose health risks over time. So even without shockingly surpassing regulatory limits, the presence of PFOA is still above the MRL highlights, and the need for ongoing monitoring and public awareness is definitely needed. I think our residents should be informed about potential exposure through tap water and encouraged to test their water and advocate for mitigation efforts to ensure their long-term safety.